us tonight. So please give a round of applause to Andrew.
Hey guys. So I'm here to talk to you guys about innovation. And I guess really I wanted to make it useful to you guys. So I'm a student as well. I'm a fourth year mechatronics here at Waterloo. And I did a startup in the oil and gas industry. And I kind of wanted to talk about three things. One, which is kind of what I did, what I've done in the industry. Two, what I've learned. And three, what I'm going to do. And really the point of each of those things is just one, to give you kind of ideas for what is possible. Two is like my takeaways that I learned. And three are ways that you can innovate as well. So you guys just came out of a workshop where you were given a really tough problem of trying to come up with a carbon neutral solution. And there are really innovative ways that we can do things. So hopefully you guys can get a lot from this talk. And I also talk about tools and stuff that I use that are pretty helpful for me. So it all started one day with a talk by Larry Smith. And it's just a very quick 40-second clip about what's your problem. Yes, there. Is it? Okay. Sorry. So I guess the audio isn't really working. But what Larry Smith talks about in the video is if you want to be a star, and for the Waterloo people, you can go to beastar.uwaterloo.ca, and it goes through a workshop. And what Larry Smith teaches is you have to find killer problems. You have to find problems that the industry has that need to be solved. And not just need to be solved, but desperately need to be solved. And if you come with a solution that actually needs to be solved and there's a business case, you will get traction. You will get people wanting to buy your product. This way you won't build a product that nobody uses. How many apps are in the App Store that are not used? That's because either their solution is poor or they weren't solving a problem that people actually faced. And that's kind of what Be a Star teaches you, is how you can do that. And that just doesn't have to be for a startup. When you're working for your employer, if you want to be a star employee, if you want to create a solution that actually has impact at the company, finding a serious problem that they have and finding an innovative solution to it will be the key to success. And that's really what Larry Smith talked about. And as Waterloo engineering, so I assume a lot of you are from engineering, but being part of Waterloo gives us an unfair advantage that no other school in the world actually has. And do you know what that is? Anyone? Co-op, and that's right. We are the world's largest co-op program. And what that means, and what that meant to Larry Smith advising all these startups, is we can come out with insider knowledge on things that happen in industry that other people and other schools aren't able to find out. You've probably done, if you go through Waterloo, 5 or 6 co-op terms. Not only that, you're in a peer of like 100 other students in your class, and they all have 6 co-op experiences. You can learn industry problems from talking with your peers and actually looking at the companies that you work at. And that's what Larry Smith talked about. So on to my co-op experience, this is me in the field in Suncor. It's hard to see out. It's a little bit cold, and this was a field day. I did reservoir engineering out in Calgary. We got to fly out to the field, and really I learned a lot about the oil and gas industry working at Suncor. And what I learned was an actual problem that they faced, which was casing integrity. So when wells were leaking, water from uphole aquifers, so water higher in the reservoir, can go into the pipelines and be produced. And it's very hard to distinguish because reservoirs sometimes have water at the bottom, and it's hard to distinguish. So I was wondering, like, is this, so I knew of the problem back then. Let's fast forward 2 years. I was interning at Facebook, and I got to learn about like the new world of data analytics and machine learning and all this new technology being used. And I was like, hey, maybe the solution to finding where these wells leak, instead of running hardware to be able to do it, let's use software, let's use machine learning. And so the idea of PetroPredict came about. And this is like a fun picture with the team and the sign, and this is in the Velocity Garage. And really what we were trying to do is use machine learning to help engineers make better decisions to identify where wells were leaking. So like life's a roller coaster. This is us pitching to the Prime Minister back then. And this was like in the middle of the summer, and life was like good. He shook our hand and said what we're doing is amazing, to the oil price dropping. So when we started PetroPredict, the oil price was way up here, starting to increase right in the past couple of years. And in that summer, it just plummeted to what it is till today. So it was pretty crazy. A lot of the interest that we got from companies were just, they didn't have the funds anymore to fund new technologies. And so that made us rechange our strategy. So I actually got to go out to the heavy oil conference and the Global Petroleum Show, and that was really cool. The Conrad Center paid for my flight. Actually, they paid for my stay out there. SPE paid for my flight, and they had like great incentives. The Calgary chapter was really awesome. We had networking events. I got to meet other students out in Calgary. I got to meet industry leaders. It was like a great experience. Got to pitch my startup, and really, I got to validate. So in that session that you did, you guys came up with ideas, and what you can do to figure out whether your idea is not good or bad, but whether it's feasible, is to go out to customers and talk to them. Say, will you buy this? And ask them to buy it. And if they don't buy it, ask them the reasons why. Rechange your product and take that idea and revalidate it. It's like a cycle, right? You build a demo, you pitch, then you get the feedback, and you rebuild a new demo that better meets the needs. And that's kind of what we did. And we had a pivot. So what we learned was business needs come first. And well integrity is a problem, but it's not as bad as a problem as something called pipeline leaks. So we decided to build a pipeline monitoring solution. Now, this image is not of our product, because I guess we're under NDA. It's taken from a website. But the idea was, instead of applying this to where wells are leaking underneath the ground, we can use the similar techniques to identify where casing is leaking. Instead of doing where casing is leaking, which is underneath the ground, we can do it on pipelines where these are leaking, and then help build a tool that enables the company to schedule in maintenance better. And that's kind of where we pivoted to solve a business need. And so yeah, this is us in work. This is being really scrappy, and that's kind of what you have to do. Like I had to store the data, because it was company data, on my own computer, so I literally went on like Craigslist and I bought a server, which is over there, set it up, got it running, and we deployed to the company. So while all this was going on, there's another great resource that you can learn about the oil and gas industry. So being a student out in the University of Waterloo, it's pretty tough because there's no big oil companies that are on the upstream or the exploration and production side. So it's hard to know what's going on, but if you are on the Waterloo network, you can literally go to onepetro.org. So I have this spreadsheet online, and this slide deck online, and I can share it with you after. But you can read industry papers of the newest technologies and applications for free on the school network. You can even use your library card and go online. And if you go to other schools, you probably have access to it as well, which is really cool. And you can read papers of things that you never knew about. Like you want to learn about drilling. The oil sands in Canada. When I was working at Suncor, I was working on Middle Eastern assets. So I got to learn a little bit about how it's operated in the Middle East. I also, in Singapore, got to learn how the oil and gas industry operates in Asia, which is slightly different. Like in Canada, we're all about operations and making sure like things are done well, things are done safe in the field. In Asia, there are these large multinational companies that exist in their Asia branches. And there they have shared assets with different companies. And it's a huge new dynamic. And I didn't even know such careers existed. And it's a totally different game. It's like completely different, and it's interesting on its own. So it really broadened my scope for what I thought oil and gas was. I thought oil and gas was Calgary. I thought it was Texas. I thought it was the Middle East. I never knew that Southeast Asia had a growing number of wells, had a growing number of explorations, and like how popular and what opportunities there were, both based out of Singapore, Malaysia, China, like tons and tons of opportunities, and that was really cool. So what I learned, this is kind of building off of like the previous talks about really the need for oil and gas. And so like one thing that we all know is that carbon emissions are increasing. Greenhouse gas emissions have been increasing. Temperature has been increasing. If you watch TV and Truth, they show that while it is complicated, the temperature and CO2 are correlated. But there are other correlations involved with oil and gas. Like sure that it's adding to climate change, and we know that scientifically. We can actually see that a lot of the CO2 comes from coal, natural gas, and oil. And the reason I'm telling you this is because these are ways that we can innovate. If you fundamentally understand how energy operates, which I hopefully can show a little bit of the graphics here, you can come out with solutions to solve these big problems. So sure, coal, natural gas, and oil is a huge contributor to CO2 emissions. And this is actually something else called the Oil Climate Index. So not only do burning fossil fuels contribute to CO2 emissions, actually producing oil and gas causes CO2 emissions as well. This is like brand new research out of the University of Calgary and the Dale Carnegie Foundation. And it actually shows the carbon and GHG emissions, the greenhouse gas emissions, of different types of oil. And we can see here in Canada, Canada Suncor synthetic crude oil actually has one of the highest GHG emissions in the actual downstream side because like refining it takes quite a lot of emissions. So not only do we have to come out with innovative solutions to come to a carbon neutral world through ways that we can reduce the use of the use of fossil fuels, but also in the way that we produce it. And there's a huge set of opportunities for innovations on that side. And that's like what the world really needs, because we will continue to produce oil and gas. And why is that? That's because if you look at the global energy flow, you can see here petroleum, coal, and natural gas. Petroleum mostly goes towards transportation, and natural gas and coal goes towards electricity and heat. India and China burn huge amounts of coal today, which is really terrible for the environment, and they're actually moving to natural gas as an alternative. But again, it's still fossil fuel dependent. Looking at GE's energy consumption, this is oil, natural gas, and coal. And you can see a huge chunk of it is fossil fuels, and these are the renewables on this side. This is BP's projection for 2035. So I didn't want to put it on the same slide because this is like real world data. This is a projection. You can see here, renewables have increased, hydro has increased, nuclear has increased, but oil and gas has also increased almost equivalently. So we're still going to be heavily reliant on oil and gas. And that makes us wonder, like, are we running out of oil and gas? And David talked about that, about the idea of peak oil, and yeah, it's shown in the United States. But if you look at global oil production, it's just increasing. And at the moment, since 1985, we've just been increasing linearly in the amount of oil and gas we've been producing. There isn't like a peak oil in terms of supply, but there will be a peak oil in terms of demand. So we're going to continue to produce oil and gas because we need it. And why do we need it? Actually, before I get to why we need it, this is just another figure about if we're running out of oil and gas. This is our consumption on the same scale as the proven reserves. So we are actually increasing in the technology that enables us to produce oil and gas at a rate that's faster than we're actually consuming it. And what that means is that we're going to continue using oil and gas, and it's going to have greenhouse gas emissions, and it's going to contribute to the environment. And kind of why do we still need petroleum? The answer is yes, there's actually a moral need. And we might not face it being in Canada, where we have readily available supplies of renewables. If you see here, India and China, the life expectancy increases as their global fossil fuel usage increases. This is taken from a book called The Moral Case for Fossil Fuels. So these third world countries use fossil fuels to become to the standard of living that we have today. Believe it or not, they need it for their medical. They need it for their clean water, right? They use petroleum energy to be able to do that. They need it for sanitation purposes. And this is like world growth. You can see GDP per person is increasing, like population is increasing exponentially, life expectancies and CO2. And it's the same with energy usage. And it's all part of the picture. So what does that mean, right? What am I going to do about it? And more importantly, what are you going to do about it? We are Waterloo engineering students, and we have the ability to change the world. And that's kind of what we've been taught since first year. We've been being taught the tools and techniques we can use so we can come out with like new solutions to do that. And the point of this is just to talk about things that I'm doing to hopefully motivate ways that you can change what you guys are doing. Or not even change, work on new projects similar to how you innovated in the workshop. So one thing that I'm working on for my fourth year design project is repurposing electric vehicle batteries. So instead of throwing them out at the end of life when they're done, so the cars they don't meet their peak voltage, instead of throwing them out, we can actually use these still good batteries to store electricity. So that's like one way. We can do energy storage, and doing it through batteries is one way. There are tons of new innovative ways that we can store energy, and there are tons of solutions, and you can read about them online. That's one thing. That's kind of our solution, just an image. Another way is actually a project that I'm doing called paper scrapers. So I started reading literature papers, and they're really hard to read and understand. So I wrote code that actually is able to pull the information from the papers so that we can better understand it. And that's the idea of democratizing knowledge. So this is kind of the results from it. So in here we can see the technique. So this is like the way that I was looking for where AI, artificial intelligence, and machine learning can be used, and then I mapped it to where it could be done in oil and gas. And that's just like a specific type of techniques. You can do that in other things. And really what that's about is democratizing knowledge. So companies now in the oil and gas industry have, in the past, been very closed. They've been held a lot of their insider information because they're publicly traded companies, so they can't release some of their stuff. But as students now, through SPE, we can go on like OnePetro, we can read papers, and we can like learn about the industry. And that's kind of ways that you can actually innovate, is like learning the fundamentals through the resources that SPE and our school provides. So I came out with another thing called petroleum101.com. That site's live. We're actually coming out with new content on what careers exist in oil and gas and kind of the fundamentals and like what's the difference between a reservoir engineer and a production engineer, or what is upstream and downstream. They were talked about in the title of the talks today, but not everybody knows that upstream is on the extraction, the exploration, the production, and the downstream is in refining. But what does that mean? What does an engineer in downstream do compared to an engineer in upstream? So kind of ways that we can take our knowledge that we've gained in co-op and share it with others. And that's why I talk about democratizing knowledge. And this is like a site that I just came out with like 2 weeks ago. It's really cool. It's called PetroDictionary.com. So you can check it out. And so there's a lot of glossaries that exist in the industry. Some that you can buy, some that are available online. This is like taking Urban Dictionary but bringing it to oil and gas. So like, I don't know if you've ever like worked on the rigs, but there's a lot of slang that goes around. Like, what's spud in? It means to start drilling. Or even like if you're reading like highly technical documents, they use crazy acronyms like RIH or POOH. You have no idea what that is. Luckily, if you work for a company, they might have an internal wiki that has some of that information, but there's no way to capture it. So as students, ways that we can innovate is take the knowledge that we've gained and share with others. And that's like one incentive that I've done. But you can also do that with your peers. You can talk about what you've done in the industry and where you can innovate in the future. So I guess that's mostly what I wanted to talk about. So those are the links to some of the stuff that I've talked about. And here's some of the resources. The site, we can put it up after, but it's my Mr. and then my first name, last name, /talk/ESS 2015. And the slides are online. So since you guys are in the industry, really make use of the resources. SPE has some awesome resources. Not only the Waterloo chapter, but SPE International. Conrad is a great resource to start doing entrepreneurial stuff. So go out and change the world, I guess.
Any questions, guys, for Andrew? No?
What's the biggest challenge you faced taking PetroPredict to the market?
Yeah, so that's one thing that I wanted to talk about, and really what I learned from the whole process is every industry has cycles, right? Some move faster than others. Semiconductor moves like at a daily rate. Oil and gas is huge, right? The impact that they have is huge. The safety involved is huge. So their cycles of innovation are a lot longer. So the biggest thing that I faced going to the market was the barrier to adoption. The idea that it's difficult to invest in new technology that is not being proven. So if you can't prove that, it's hard for you to build a tool that people will use that will make multi-million-dollar decisions off of if it's not been proven for many years. So it creates a chicken and egg problem where you come out with a solution that needs to be validated, but it cannot be validated because it hasn't been validated yet. So how do you solve that chicken and egg problem? And the way to do that is go back to what I said, actually solving a true business problem. So if companies are facing the problem and it is a desperate need, and you come out with a solution that actually helps address the need, if it truly is that desperate, they will be willing to pay or at least try it out. They'll be at least willing to listen to you to what you're doing and see if it's a good fit. The second thing that you can do to face that barrier to adoption is going through that lean life cycle of coming out with a demo, pitching it, getting feedback, and changing it based off the needs to find that problem. Because you don't know the problems that exist in industry because you're not working in industry. And even if you are, you don't know the global problems. So being able to cycle through and maybe move from maybe taking a technology that works in one thing that you think is a problem, but actually solving a different problem with the same technology. And that's what I found. So the barrier to adoption and trying to overcome that.
So thank you for the presentation, and I just wanted to ask. I'm not sure how much information you wanna get into, but I just wanted to ask exactly what does the program with PetroPredict software do in comparison to what the companies have already been doing? Like, what's the difference between using software and using an actual physical hardware?
Sure. Okay. So I'm gonna keep my answer to the downhole side very brief. Our solution was that we could use data analytics to help companies make better decisions before they have to run the hardware. Because when you run a workover or an operation on a well, you have to shut the well in, stop production, and then run tooling, and that costs a lot of money. There's lost production. We were trying to create a tool that helped engineers make better decisions. But the problem that we were solving was not as large as pipeline risk. So pipeline risk is a larger problem that's faced more widely in the industry, and there are solutions that exist that do risk modeling. The difference between what oil companies are doing right now compared to what we're trying to do are oil companies, they're really focused on day-to-day operations. They want to make sure that they're operating and that the safety is there. They don't have enough capacity to also try and innovate and try new solutions in that space. So they were using existing technologies that already existed, which was mostly Microsoft Excel. They had a large list of pipelines that existed in their thing. It was like a spreadsheet with over 150 rows, and I think it was 7 megabytes. It was just huge, and it would grow and it would crash and it would be terrible. They didn't really have the ability to put that information into a database and the ability to build a tool that enabled them to make the decisions that they needed. They had a tool that plotted where their pipelines were, but they were doing the actual analysis of where it was likely to fail and how much it would cost manually by hand, which is a very time-consuming process. So what we did at PetroPredict was we were able to take publicly available data on current pipeline operations and spills, and you can get that from the Alberta Energy Regulator. You can download that data from there. It's open. And so we were able to impute values from what was released publicly across the province of Alberta, and then apply it to their closed data within their daily operations. So we were building a tool that helped the engineers make better decisions.
Okay, Andrew, thank you so much for your presentation. So much answers. That's